So welcome to Vansik Maths. This is a Kcse 2024 paper 2 probability question. It's a 10 marks question. So before we proceed, remember to subscribe. The question was asking the probabilities of obtaining scores 1, 2, 3, 4 and 5 using a biased pentagonal spinner were recorded as follows. So you have the score 1, 2, 3, 4, 5 and their probabilities. For obtaining score 1 is K, score 2 is 0.1, score 3 is 0.25, and score 4 is 2K. For obtaining score 5 is 0.2. So the first part, determine the value of K. So in probability, we usually say that when you sum all the probabilities, the sum of all the total probabilities, they should give you 1. That's why you find that the probabilities are always numbers less than 1, so they should add up to 1. So that first part, if you want K, so you are going to sum. You have K plus 0.1 plus 0.25 plus 2K plus 0.2, it should give you 1. So you can collect the like terms, K and K, we'll have 3K. Then 0.1 plus 0.2, this is 0.3, 0.3 plus 0.25, we'll get 0.55 is equals to 1. So we'll have 3K will be equal to this to the other side, 1 minus 0.55, we'll get 0.45. Divide by 3 both sides. Now you'll have 3K is equals to 0.45. Divide by 3, divide by 3. So your K will be 0.15. K will be 0.15. Then this one is, for getting score 4 is 2K. So it will be 2 times 0.15. This will give you 0.3. So they were asking the probability of getting the score of 4, another 1 mark. So you have said if K is 0.15, then 2K will be, you multiply by that probability, you get 0.3. Now the next part, they are saying that the spinner was spun twice. Calculate the probabilities of obtaining even number in the first spin and odd in the second spin. So in the first spin, first of all, you need to find the probability of getting even number. So for the first spin, for you to get even numbers, we know that the even numbers there are 2 and 4. So you have 2 and also 4. But these events are mutually exclusive. Mutually exclusive. If you spin once, you cannot get 2 and 4. You can only get 2 or you can get 4. So it means if this one happens, it excludes the probability of this other event happening. So you have the probability of either getting 2 or the probability of getting 4. That is for the first spin. So the probability of getting 2, it was 0.1, and we know what OR means, so you have plus. The probability of getting 4, we have 0.3. So when we add, we'll get 0.4. So this one is the probability of getting even in the first spin. It is 0.4. Now what about the second spin? They were saying that and odd in the second spin. So probability of getting odd in second spin. So odd numbers are 1, 3, then you have 5. But then again, 1, 3 and 5 are exclusive events if you spin the second time. So you can either get 1, or you can get 3, or you can get that score 5. So probability of getting 1 is 0.15 plus probability of getting 3 is 0.25, then score 5 is 0.2. So the total probability of getting odd in second spin now it will be 0.15 plus 0.25, which is 0.4 plus 0.2 gets 0.6. But now you have to remember again, the first spin was even, the second spin was odd. So it means probability of getting even in the first spin and probability of getting odd in the second spin, these events are independent. These are independent events. It means you can get an even in the first spin to not affect the probability of getting an odd in the second spin. So if one event occurs, it doesn't affect the probability of the other event occurring. So here you can get even and can also get odd in the second spin. So you'll take the probability of getting even in the first spin, then multiply by the probability of getting odd numbers in the second spin. So in the first spin it was 0.4, multiplied by the second spin, which is 0.6. Now you have 0.24 as the probability. Now after finishing that, now the last part, they were asking the total score for the two spins obtained, the total score S for the two spins obtained, determine the probability that S is greater than 9. S, the sum is greater than 9. So for the first spin we have all these numbers 1, 2, 3, 4 and 5. Again for the second spin we have 1, 2, 3, 4 and 5 possible outcomes, but you realize that if you want let's say first spin you get 4, if you want it to be the sum to be equal to or to be greater than 9, so automatic the second spin will have to get 5 so that it can be 9, it can be equal to 9. Or the first spin you can get 5, then the second spin you can get 4, so it will be equal to 9. Or the first spin you can get 5, and the second spin again you can get 5, so that it can be greater than 9. So we have the probability of getting probability of getting 4. Our probability of getting 4 was 0.3. Then we know that the probability of getting 5 is 0.2. So we are saying that for the first spin, if you get 4, then the second spin you get 5. Now which kind of events are these? So we have probability of getting 4 first spin and probability of getting 5 in the second spin, or you can get 5 and you get 4 in the second spin, or another alternative, you can get 5 and again you get 5 in the second spin. These events are independent events, so you can get this and this. This happening does not affect this one. That's why we are doing AND. But exclusive, these and these are exclusive. If this one happens, it excludes the probability of this other event happening. So you know probability of 4, which is 0.3 times now 5, which is 0.2 plus again 0.2 times 0.3 plus 0.2 times 0.2. Now we shall